Everyone, I want to thank you very much for coming out tonight. It's always good to support a club member in their adventure of what they've done and to share with you and to learn from them. So first of all, with every presentation, I do want to do the Pledge of Allegiance. So everyone stand up, hats off. I pledge allegiance
to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
Thank you very much. A very nice turnout. I know other people are still in the other room just chatting away, but they'll eventually come in. We have chairs up in the front here.
Yeah, there's 3 chairs here, guys.
Total 4.
Please use them.
Want to
Come on, out of the doorway. Come on, Gary, you can get out of the shadow.
Have a chair up over here, sir.
Mr.
There.
Cantor.
Good evening.
Hey.
I didn't warn Nancy you were coming. Come on, up here, guys. We have chairs here and here.
Yeah.
There's no reason for someone to stand right here. We got a chair.
This is
Oh,
all.
you got Kevin over there? Kevin, you got a chair there?
Actually, somebody was sitting
Oh, well, it doesn't make a difference.
Yeah, we got another one up here and there's one there.
Okay, everybody. Gordon, what I want you to do is just take it from here and just explain everything and, do your own thing. I know you're very involved with events, which is very good. Which is very good. A lot of people do follow you and come to the club because you
Yeah, I keep checking the bottom of my shoes to see what I'm tracking in.
All right, everyone. Gordon.
Thank you very much. Thanks to everybody for coming tonight.
Thank you.
Basically, what we're going to talk about tonight are a couple of things. We're going to talk about our technology and how we implemented it, and all sorts of crazy questions about some of the strange elements. But we're also going to talk about what an amateur radio operator or a team of amateur radio operators bring to any endeavor. Because, ladies and gentlemen, when you look around you fundamentally represent some fractional percentage of our society's, shall we say, capabilities. And what I mean by that is that we are, as my former boss said, the solution to the problem, waiting for the problem to show up. We come with a lot of skills, and so you're going to see how that builds into this a little bit. And if it's not clear, then we'll be happy to go further. I'm not going to do a great big huge hoo-ha demo tonight, but I do have some things to show you that are live and operational. So it all starts, at least everybody thinks so, early in the morning. In fact, let me put this in display mode. So everybody thinks it starts at dawn on the day of the event. And this is the finish line. As dawn is, pre-dawn hours, it's about 5 a.m. And, I just had to take a picture of this just to see, what it's like to really drink in the serenity of Central Park West early in the morning. And I thought about everything that went into it. Most guys who work the marathon, there's what, 300 or 400 people, 400 or 500 people, pardon me, who volunteer for the marathon every year. And most bring a mobile rig and maybe an HT or two, and they're pretty much good to go. And it really got a lot more complicated. It started with a phone call from Mike Huft saying, "Hi, my girlfriend Deborah is the coordinator. She is the new Steve Mendelson, if you will, and she would like to know if we could run some form of data connection between the amateur radio comm trailer and the race control center, which is this massive tent that comes complete with a hard floor and lots. It is basically an EOC and command post all rolled into one. The incident commander is the race coordinator, and that person coordinates every agency that's there and has deputy mayors, and commissioners and their immediate subordinates basically answerable to him for the period of the event. So there was a little bit of, shall we say, nerves surrounding what was being asked. We were told, yes, you could see between the two positions. We couldn't guarantee when you got there on race day that someone wouldn't build something in between or park an electronic news gathering truck or some other godforsaken, vehicle or an emergency response vehicle squat right in the middle of your path. So we had to be ready with all kinds of, alternatives. So 500-yard path is not a big deal, in normal sense. RF should work. Well, except for the fact that we use 2.4 gig Wi-Fi, we use 900 megs, we use 5.x gigahertz, we also use 3.4 gigahertz, and that's ultimately what we came down to using. But we went through a whole decision process as to how to pass, how to deal with that, because has anyone ever been on the finish line at the New York City Marathon? Yeah, Gary. Yeah, Gary and me, I think are the only two in the room. But your cell phone does not work. I mean, if you've been to the Fairlawn fireworks or something similar like that, and everybody takes pictures of the fireworks, well, and then immediately their cameras are set up, or their phones are set up to immediately upload. Steve, we got a chair right here.
Thank you.
Immediately the cloud is being loaded up. Tony, I got a chair for you wherever. Come on over here.
I didn't know I just started.
Yeah, Tony. It's gonna be a little tight, but I'm gonna need that because my knees aren't gonna handle this all day. But anyway, the cloud gets, starts sucking up all this data, and you hope to God that you have connectivity. So that's a problem. But then they said, well, we want to run a closed phone network. We wanted to run, and ultimately the requirements changed. We wanted a data port for each of several operators associated with that phone, at least one. And, oh, by the way, at the last minute, someone said, I don't have an Ethernet port on my iPhone or iPad, and therefore you must. This was a Saturday morning request, where requests aren't requests, it was get it done. So I had to put together an access point and hope to God that for the 10 feet of space that we had this guy operating near it, that it wouldn't get hammered by other people's access points and everything else. So there was a lot of that. And then we wanted an internet gateway because there's a Google Doc that was up in the cloud, and that had to be supported because that's how people at One Police Plaza and other locations around the city would be tracking the status of the event. So it wasn't just the race control center on the amateur radio trailer. There were other people with eyes on the data in real time. We also wanted, we had requested that the Roadrunners provide us with an internet drop at the trailer. As it turns out, they gave us one that was just tough to use. It was just awful, in a word. So that became a bit of a challenge. What we did was we unplugged the access point and we took the Ethernet cable and shoved it into the mesh network as a gateway port. And then we found out that their capacity was just terrible. And that was at our trailer side. And so what we ended up doing was we ended up toughing it out for a few minutes during the event. But next year we have a lesson that we learned, and we found out there's a ridiculous amount of bandwidth available at the race control center side. So we're going to feed the trailer the other way. We're going to support the trailer from across the mesh instead of supporting the medical people at the race control center via our internet connection. So we did learn some things, and you'll see that in the topology diagrams. But the last request was for, can we enable direct dialing into the Roadrunner's telephone network. And that turned out to be a flat out no. I mean, they asked, but, no, our phones, we could have set it up with more time, but the Roadrunners weren't very forthcoming. Even though the request was from them, the ability to provide support for that, it was hampered by their technical people. Question? Okay. So at the high level, the network kind of looks like this. You had the medical control center, which is inside the race control center. That's what they were to get. So we use Randy's M3 rockets, which are devices that look roughly like this, except the antenna is a 2.5 foot tall sector antenna, about 150 to 160 degree aperture. So the antenna about A-high, weighs a good, 15 pounds, easily. Built like a brick. It has one of these transceivers strapped on the back and bottom of it. And we chose 3 gigs for one overriding reason. No Wi-Fi, no intermod from Wi-Fi, because we can step outside the normal Wi-Fi channels. And we'll talk about that in a bit. We didn't want to deal with 5 gigs. And 900 meg with all, which is an ISM band, well, we have it as a ham band. So does every other Tom, Dick, and Harry with their Part 15 devices. And let me tell you, I don't have them here, but I took screenshots of what a spectrum analyzer saw 100 yards from, or 200 yards from the finish line with just a rubber duck, and the noise floor at 900 just became ridiculous. It was roughly around minus 25 dBm. I mean, it was crazy. I mean, it was like, wow, that's a lot of RF. Somebody wasn't playing by the Part 15 rules, I'll leave it at that. There were a lot of people not playing by Part 15 rules in the park. Similar things happened at 2.4 gigs. Now, I should point out the AREDN software that we use, the Amateur Radio versus Data Network software, does operate with a couple of things that you can do that help slice and dice a better signal out of things. Number one is you can go to an equivalent channel -1 or channel -2. So you can step away from channel 1. There's no way to be on quote channel 0 because the software limitation 0 means things in code. But you can go to -1 or -2, and by doing that we can actually shift into the ham band and away from regular Wi-Fi. When you do that, you can also decide to, or not, you can actually narrow your bandwidth from the standard 20 megahertz wide, 2.4 gigs. You can go down to 10 megahertz or to 5 megahertz bandwidth, which improves your signal to noise ratio. So if you want to pick up 6 decibels, you go from 20 megahertz wide to 5 megahertz wide. Everybody catch that? Cut it in half twice. You get 3 dB each time. You're 6 dB. So that's how you do that. That actually was something we did consider, and we actually did run some test links in the park during this event just for hoo-has. We didn't tie them into the main network, but again, the noise floor went way up. That probably minus 40 dBm, minus 35 dBm at 2.4 at various times in the regular Wi-Fi band. We did not do anything at 5 gig. We had no trouble at 3 gig. We were low enough in the band so that the licensed 3.65.
The
Sorry?
monitor's out. One on the monitor.
Oh, sure. So the license, here we go. So the license stuff didn't, that's a 365, which also exists. We were 300 megahertz away from it, so we managed to survive that nonsense and do well. So looking at this, why do we have an M2 nanostation as well as the rocket and an air router all there? So the first thing was that the rockets were the M3 rockets were providing connectivity between the 2 locations, but there's a software limitation in the AREDN boxes that the most DHCPs they can give out IP addresses, if you will, is 13. So we didn't want everybody getting their, we didn't want to run out of IPs. And why would you run out of IPs? Well, I have 2 PBXs. We'll talk about why we have 2 PBXs later. We have a number of laptops, 6 laptops. It turned out, I think ultimately it was 7 or 8, plus a bunch of Wi-Fi devices, as I mentioned, people with their iPads. We had 5 phones. That turned out to be 6 or 7 phones in the end. And we also had the Cradle Point Gateway. In this box here, this is a mechanically different but electrically the same configuration as what we had for the Marathon for one of our nodes. The other node being literally a breadboard. And we'll talk about how we got that done. But there's a cell data card in here, which during the ramp up, we weren't sure when we would get internet turned on. And that was also a wise move because the internet was turned on around noon on Saturday, and then somebody unplugged us because we were being fed from an ENG vehicle, electronic news gathering vehicle that ABC was having, and their technician said, "Oh, that's not my cable," and just unplugged us from their patch panel 2 trailers away. Well, gee, thank you. So that took a bit of an escalation. Actually, Commander Rob Scott, if you know him from the State County Sheriff's Department, he, in his amiable way, went on the door. And the way I can describe him is he's got a big, huge, smiley face, and he's built like a combination of, I don't know, maybe if you merged Van and me into one body and then shortened it by about 6 inches or 5 inches. That's Commander Scott. So I'm sure when the person opened the door and saw teeth and a smile and a big, massive personality, I'm sure that made an impression. He's quite the character. In any case, we did get that up, and that was worthwhile. As I mentioned, we had 2 PBXs, and this is what happens when you overlay everything into this. So the physical connectivity are those fine blue lines that are in the background, and this is essentially the telephone diagram. And number one, we had phones that mercifully were all identical. We used these Grand Stream phones, and they have 2 lines. And we assigned an extension to each of the 2 lines. One was configured for my PBX, and the other was configured for Mark into MH's PBX. That way, if one of the PBXs died, it wouldn't matter. In fact, if you dialed the number for the other station, or for one of the telephones in the other location, what would happen is, let's say you dialed from my PBX, the corresponding line on that person's phone would ring on their PBX, from my PBX, and then the way Mark set up the routing tables, it also forked the call and sent via a switch-to-switch trunk, which you can see here, this line here, and brought up, it rang the second line. So whatever switch you were on would ring first, and it literally, maybe 300 milliseconds later, you'd see the second line, or the first line as the case may be, light up as well. So you didn't matter which line you answered, you would always get the person. And that way, if the switch, we tried to make it stupid proof. And when you see the pictures of the inside of the trailers, you will, and then think about the operational chaos, reducing human factor errors is what we were all about, not to mention technology errors. The other thing is these phones have the pleasure of having a port on the bottom so you can plug in your laptop. So you plug in a network port on one, and the other port you can plug in your laptop, and that worked well as well.
Gordon, can I pause you?
Yeah, let's take a break. What do you
Without definition, you've used a couple terms, which
please.
some of us know, some of us don't. Would you clarify for everybody, what's the difference between a mesh node versus an access point, first of all?
Okay?
Secondly, what is a PBX? What is an IP phone? This is probably about it.
Okay, those are all good questions and worthy of an answer. So, I flip back here to make it simple. So, we have a couple of different things. This is IP space, so Internet Protocol, and largely everything in blue is wired. That's why they call it wireless, right? Look at all the wires. So we did a couple of things. The nodes, these two will communicate, via the switch. We put them on different RF channels. All three of these were on different radio channels. So their networking was actually through this switch, just like your home router. This rocket was actually the only wireless piece in our mesh node configuration that was actually cut to production. We had, as I said, we had other bands just in case. But what happens with the mesh nodes is you give it a network name, let's say AREDN, AREDN, dash, and the version number and the bandwidth and the version number. And that becomes its SSID. Just like your home router might have my home router, or in my case, W2TTT hyphen FN30 hyphen, I forget what I have mine. I've got a couple of different ones in the house. But the point is I have those as an SSID. If they see another node with the same SSID, they establish a link automatically. And then they do something else. They say, oh, who do you hear? So, for instance, if you were sitting here on this M3 rocket in the tent, this rocket would tell that rocket that it knows about this nanostation and that air router. Okay? And similarly, these guys would exchange information. They're doing it over the wire. That's great. So let's take a quick look over here just to make things, to illustrate that. So I'm on a node, which is that flat one facing down next to the projector, that big square one. And it has a wired peer. So it's got two wired peers. One that's buried in the box, that's the one that's labeled 5, the AG5 for Air Grid 5. And also the rocket, that's the one I held up before. That's this guy here. This is the M2 rocket. They're all wired together. So if I go over to the M2 rocket and I look at its mesh status, you'll see it's got new friends. So it knows about the mobile Air Grid 5 and it knows about the mobile Nano Loco 9. Those are the two that it's wired to. But it's also seeing another node that's right here. That's the one that's supporting the camera. And it also sees W2NPT Rocket 2, which is on top of the building here. So all of these are make friends. And then once they make friends, they say, who do you hear? And they repeat that process every few seconds, roughly half a minute or so. And they, shall we say, provide routing updates. So that who are your neighbors and how strong are they? Who are your neighbors and how strong are they? Now, we use a least cost routing algorithm called OLSR. There are other mesh protocols and routing algorithms to go with them. But the one we use in AREDN is OLSR. It requires no central administration to come up. As long as you know the network ID and it defaults, it magically will come up. The only requirements are SSID has to match, the channel has to match, and the bandwidth has to match. Remember I said you can go from 20 to 10 to 5. So a lot of us, as a matter of course, will run channel -2, 5 megahertz, and the latest AREDN version. In fact, there's some versions, let's say major releases, we're release 3 right now, right? So, right, Randy? Release 3.
The current stable version is 3.16.1.1.
Right, but a 3.16 will talk to a 3.17, it'll talk to a 3.15, blah, blah, blah. It won't talk to our release 2. for obvious reasons.
Again, what are the three pieces that are connected on the table, and what does each one do? That you
Okay.
have right here?
Yeah, so they're kind of proxies for what I had here. It's similar to what we had at the marathon. I have one embedded in the box.
Which does what?
Its primary job is the housekeeping node for this box. That's the way I've set it up. So that way, no matter what, you'll have an IP address, you'll have some ability to mesh, albeit on 5 gigahertz, 20 megahertz bandwidth on channel 133. Why channel 133? It's far away from where everybody else is. You know, that was my primary motivation. And so I run that in there. So all my little portable and mobile nodes, if they have a 5 gig node installed, will have that. And that way, without having to do any thinking, with respect to other things that I might want to do with that box, I don't have to physically connect them. I can immediately build a mesh network on 5 gigahertz. Or even if it's just between, you know, my ham shack, my basement, and my car, or my garage. That stuff will immediately come up and work. The other two nodes, in reality, this would be on a longer pigtail on my, this is actually all going on my car roof, but with different antennas. But this will be my 2 gig node, and this will be my 900 node. And they have, while they have, well, this one has a built-in antenna, this one does not. The antennas are actually provided on the roof of the car. But they're similar in configuration to what we had here. These are all over-the-air boxes.
Okay, so you've explained what the
nodes
what
are.
the nodes do.
I'm going to get to AP and PBX
Oh,
next.
okay.
I haven't forgotten. So, an access point. Your home router, when you take your phone or your tablet out or provision a wireless smart TV or something, you access that home router through its access point, or AP. Okay, and you set up and yet another SSID, right? That typically has, you know, either 2.4 gig or 5 gigs or both, and your device, if it's smart, can leverage as much bandwidth as possible, and you'll have fast wireless internet connectivity in and around your home or your office or wherever else. So you know, that's just standard. You know, put in the SSID, put in the security code, and you're good to go.
The SSID is the name that we see listed.
Yes. So if you bring up your phone right now and just scan for networks, you'll see that there's a network for the community center that has all sorts of ports blocked. You basically use port 80 or pretty much die. Then there's the Fairlawn Radio Club one. You'll see one that's here. Oh, I didn't mention here, this one has an AP inside. I don't really want to irradiate Steve excessively. But there's actually an AP built into that too, a wireless AP. You did that already. Anyway, and he's not a good progeny, I'll point out. But anyway, but the point is that's their basic access point, or AP.
Right, so your computer cannot wirelessly connect to the mesh network directly. It needs the access point to be in between your wireless.
Right. And in fact, while that computer, your cross computer, is hardwired into the mesh network right now, I could actually bring this one up totally wirelessly. But if you want to horse around, my mobile node has a password that's similar to its SSID, and you should be able to figure it out. It's not rocket science. I don't want to say it on tape since we're being recorded here, if you don't mind. I appreciate it if you wouldn't either. Although Tom can edit anything. The third question was PBX. That's actually a legacy telephony term, or private branch exchange. Basically, it's a phone switch, okay? And, you know, in the old days, you know, you had tip and ring on your wired connection for your home, and went out to a central office, and, you know, when you took it off hook, it would get a raised dial tone, you would get, you know, dial tone, you would type in some digits, and they would go off en route through the magic of the class 4 and class 5 switches that the North American, pardon me, that were popular in North America, courtesy of the Bell system. Those would give you your landline connection. Well, over the last, maybe 3 decades or 4 decades, I guess, almost 4, we've taken this internet protocol that we all know and love and said, well, gee, we can go one step further and we can put voice over an IP connection, or voice over IP. And that's what these phones do. So the way a VoIP call works, it's kind of interesting. So the first thing you do is you tell the phone which PBX you're going to talk to. And line 1 is one account and line 2 is another account. They don't have to be on the same switch. In the old days, wherever the wire went from your phone, that was who was going to switch your phone call. Now, it's wherever you decide to send the packets to is going to have your call completed. So we've all seen Magic Jack, right? Everybody's seen Magic Jack or Vonage. Well, they have basically big computer networks that go over your IP from your broadband in your house and go to their server, and they go, oh yeah, we know Steve's line, blah, 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 and he has a password, and it's all encrypted and all that good stuff, and it registers the phone. Now the phone is free to make calls. So what it does, let's say I want to call from this phone to this phone. Line 1, switch phone 1 to phone 2. Let's keep it real simple. What I'm going to do, let's say they're both registered on, for our purposes, on Mark switch. Both these have live capability. That you say to Mark switch, I want to talk to the runner dropout net, and that's over here. Okay, so you dial the digits for the runner dropout net. Let's say a 4-digit number or 7-digit number, whatever you want to make it. The PBX will say, oh, it takes that 4-digit number and says, that's on IP address over here. And what it says is, okay, so it will then ring his phone on that IP address, on the other IP address, and tell this phone where you are, what your IP address is. Okay? And if it completes, it sends you a complete back here and tells you what his IP address is. Now you both know each other's IP address. So now the traffic doesn't go through the PBX, it goes back and forth directly between the two phones. So the switch can say, I'm out of here. Now, if you have a conference bridge or you want to do recording or you want to do some other specialized functions, then yeah, you're going to run the traffic through the switch. But normally, once an IP call is set up, the connections are device to device, phone to phone. In fact, I didn't bring it, but you can have voice clients, voice over IP clients for your tablet, your phone, your PC, and you can turn those into a voice over IP phone. Yeah, there you go. Exactly. Actually, Gary, I could probably, maybe later on after the thing, I could plug this phone in to the network. We'll get an IP address, and then you could just do if you can do IP dialing from your.
Not through Magic Jack.
Okay. That's Magic Jack. Okay. No, if you have a voice client, here's another thing you can do. If you don't have a PBX, and we actually built this into our plan for the marathon, we said, okay, what happens if both PBXs die? By the way, we ran those on separate power. We were totally OZ. And when you see the pictures, you'll get it. Everybody had a list of what the IP addresses were for every phone in the network. So instead of dialing a 4-digit phone number, because we had things like, let's say Logistics North, LOGN. You literally dial, if you wanted Logistics North or Logistics South, LOGN, LOGS. And they would ring on that person's desk on both lines, like I described before. But if you had no PBXs, you had the IP address of Logistics North, and you could enter 10.x.y.z and hit send, and it would actually call directly between people.
The
Or was
monitor
you-
went off.
Sorry?
The monitor went out.
No, Margaret,
Find out.
Gordon, what was the difference, you know, was there a difference in call quality between the phones in the trailer and back and forth
No.
to the tent? That's
No.
awesome.
it was absolutely stellar.